and welcome. Today we're solving the question balanced binary tree. So let's get started. So the question is, given a binary tree, determine if, let me see if I can just, yeah, I cannot move it. So given a binary tree, determine if it's a height balanced. So height balanced tree is a binary tree is a binary tree in which the depths of the two subtrees of every node never differs by more than one. So what they're basically saying here, if we look into the example here, so let me look at it again. Binary tree is a binary tree in which the depths of the two subtrees. So what do we mean by the depths? Is let me see if I can. No, I cannot pull up I cannot annotate, but still okay. So they mean the depths is basically uh, like as we go down the tree, right? We get the depths of the tree, and uh, in which the depths of the two subtrees of every node never differs by more than once. So say here the depths of the left subtree are from the root node 3 is 1, right? And the depth from this side is 2. So 2 minus 1 is 1. So this is basically true. And this, if I may say, phenomenon is true for all levels in the tree, right? And for all the nodes. Say if the say the depth of the from this tree, right? The left sub like the left depth is 1 because there's only one node there, 15. And what about the second? So we have 7, and what we are getting from this is that the depth is 1 minus 1, which is the depth difference is 1 minus 1, which is equal to 0. So looking into this tree, right? So the right subtree is 2. Uh, sorry, the depth of the right subtree from the root node 1 is 1, because we only have one node to the right of it. And the depth to the left is 1, 2, 3. So 3 minus 1 gives us the difference of 2, and this is going to result in false. And yeah, of course, like while we are solving this question, I want to use the depth first search method. While I want to traverse through this tree, like bottom up. So I want to go all the way down as possible, right? And when I don't have any node, let's say like I think I want to return the depths. So because I want to compare the depths and base my conclusion on that. So when I don't have a route, like say when I want to traverse, like as I go through this, I want to go all the way down. And once I'm at 4, I want to try to go to its left subtree because while we are doing while we start initiate the depth first search, I want to start it from the left subtree. So as I traverse down the tree to the left and I have no more nodes left, I want to return 0, right? So this returns 0, and I want to try to go to the right subtree. So, and the right subtree also returns 0. So when I get the 0, I want to compare and to get the absolute value. And the reason I want to do the absolute value, I don't know, say, uh, I only care about the difference, right? If the say left subtree is 2 and the right subtree is 0, or say the left subtree is 0, and since we are subtracting right subtree from left subtree, or left subtree doesn't matter, but as long as we can get the difference and the difference is less than 2, right? As long as it's less than 2, we want to return true. Otherwise, just return false. Okay, so we say but interestingly, we just don't want to return true. We want to return the maximum depths between the two if, say, if the difference is, say, less than 2. Wait, yeah, if the lesson is less than 2, I want to return the maximum between the left subtree and right subtree. And the reason I want to return the maximum is because if I return the maximum, right? Say if I return the maximum from this left subtree, which is gonna be say 1, 2, 3, yeah, 3, right? So I get that 3, right? Instead of getting 2 or 1. So I want to return the 3 and say, and I want to say, okay, once I get that 3 from the left subtree, from this node, I try to go to the right of it, and I get, what's it called? 2. And the difference of 2 is not acceptable in our case, so I want to return false from this function. So as we said, I think I went like a very like into the question, but in order to like if we work our way through this problem, I want to say what we see is this is a tree question, right? This is a tree question, and can we come up with any edge cases that might prevent from our solution that we've planned so far? So one thing, what if the tree is just empty, right? What do we want to return? Is it balanced or not? So I think as long like if there's no tree, this means it's a balanced tree, right? Or let's see if we have any. Yeah, I assume if there's no tree, we can just return true as they specified right here. So we got one edge case, if I may say, eliminated. Say, can there be negative values in the as a root value, right? If there's a say root value of -4, and I'm trying to find -4 minus, say we got oh, since we are calculating the depths, we actually don't care about the values of each node. We only care about the depth. So I think the node values can be negative, but it doesn't really matter for us because we only are using the depths, which is going to be 0 or a positive um, or a positive, how do I say, positive number. So not negative number. So we got the understanding part down, and let's match it to the any data structure that we know. So it's a tree, and we decided that we want to do DFS bottom up, right? And going into the planning section, I want to say I want to go all the way down, right? And then if until there's no more nodes, right? So when there are no nodes, right? When there are no nodes, return 0, right? Uh, say, um, and then at each level, say when we go down, we want to return if there's no node, and we want to return and do the same thing to the left. I can say the get the depths of the left and right subtree, right? And once I get that, I want to return the if say if the depths of the say if the difference, right? If the difference, absolute difference is greater than 2, I think I can just return. I can just return. So I'm actually thinking, what if I just return like a array where I can store the first value would be true or false, and because say if the first value is false, I don't want to bother uh, checking the difference, right? So have a data structure like if there's no node, uh, return true, and then the depths. Okay, so we want to return the depths. Want to return true and then the depths of the actual tree. So, and if the absolute, and I want to check if if the left and the right. So if we have both of these subtrees true, right? Uh, then I want to check the say get the maximum difference, the absolute difference, and then return. And I want to return true if the length, if the difference is less than 2, else I want to return false. Yeah, if it's true, I want to return true, and then I also want to return, say, uh, the maximum between the left and the right subtree, the depths of the left, so maximum of depths and left subtree, because we want to use it later, like on the upper level. So um, let me see. Yep. So else return false. Yeah, we just return false otherwise. So I think we will need I will make a helper function, which I'll call DFS. To this DFS, I'll be passing root, and don't want to forget to call it right here, return DFS passing in the root. So if there is no, say, root, right? If we don't have anything, or we just reach the like the end of the max, like the last steps of the binary tree, I just want to return, if not true, I want to return true with 0. All right. But if there is a root, right, I want to go as much as I can to the left. So DFS passing in uh, root dot left, and after that I also want to do it on the right. So root dot right. So I will say this one is going to be left, and this one I would indicate as right. So once I get these, I want to compare these two, right? I want to say, uh, how do I compare them? So if left and right, so I think, uh, yeah, if I have both of, if left, that I think I should take the first value. If both of them are true, right? If both of them are true, I want to uh, return true, and then I also want to say left and left at, wait, yeah, I only want to compare if both of them are true, right? In this case, I would say if we have both of these, then I want to say get the second one, which will be left at 1 and right at 1, right? So left at 1 minus right at 1. This is the depths, right? So I think I should make it clear right here. So status, or yeah, status and depths. Because if it's false, right? If I have found that there's no uh, the tree is not balanced in the lower levels, I don't want to bother checking the or comparing the depths of these subtrees on an upper level. I just want to return false. If left at, say, the first values are true in both cases, I want to say left at 1 minus right at 1, which is the depths, and I want to take the absolute value of these two depths. So I'm gonna say depths, right? And then I want to say if depths is greater than 2, I want to return false, and the maximum of left 1 and right 1. Otherwise, I want to return, I think I should say else. So I think I can just say if depth is less than 2, in this case, return true and the maximum. Otherwise, I will just exit this full entire uh, if statement, and then return false with the maximum of left, and then maximum. I actually don't need this. Uh, I guess I actually don't need this, uh, but let's try it without, right? So if there's no root, we're returning true. So I think I should make it clear that I want to return the first value. So if there is no root, in this case we have the empty tree, it's balanced, so we want to return true and depth of 0. But say we have the tree that looks like this, and we want to go all the way to the left. So I want to say left is going to be equal to DFS root dot left. So I try to go as left, like as deep as I can to the left. So once I'm at 4, I try to go to its left, from which I am going to return true and the 0. All right. When I do that, and then I try to go to its right, and the right is gonna be return true and the 0. And I say if there's left and the right, if both of these are true, I want to return depth is equal to the absolute value of the left and the right. So we get the depth, which is gonna be 0 minus 0 will return us 0. If depth is less than 2, we want to return true, which is as the first value, and the maximum of left and 1. So in this case, it's just gonna be, I think maximum of left 1 and the right 1 plus 1, I guess, because the reason we do that is because we have 0 and 0. Oh, wait, do I actually need this? Uh, yes, because left at 1 was 0, right? And then right, so once we returned here, we had both of these 0, and from here I want to return maximum of left and the right plus 1, which is going to result in 1 in this case. So it's going to return 1 up here with true, and it's going to try to go to its right subtree. And when I try to go to the right subtree, I do the same thing, and from here I will end up returning true with 1, and I get the difference. Yeah, so I'm trying to look for any possible errors here. So if the left at 0 and the right at 0, right? Then we want to go to the depth equal to the absolute value of left. So if I as when I go as deep as I can, and oh yeah, because that actually makes sense to me right now. So from 4, I try to go down, but I have no more nodes, so I return 0 with true. Same here, and then I return 1 plus 0, maximum, which is going to be 0 anyways. Mm, I think I don't need this. Maximum of left at 1, right at 1, plus 1. Okay, and then I want to say from here, I return 1. From here, I return 1 to get the maximum of both. In this case, since the depth is less than 2, uh, and then return 2 right here. So I return 2 from here, 1 from here, and then I get the difference, which is less than 2, and return true and the maximum plus left. So maximum was 2 plus 1 is going to be 3, and then this side is going to be 3, and this side is going to be 1. And then from this one, I try to say, okay, if left 0 and right 0, right? If I have both of these set up, and then I want to return the depth, which is going to be equal to the 3 minus 1, in this case it's 2. I don't end up returning anything, and I'll just return false. And from this node, I will return false, and I return false over here. So as we have reviewed this solution, I want to also evaluate it. So the space complexity would be all the nodes in the tree, right? Because since we are doing this recursively, uh, or say, yeah, so I think it's gonna be the size of the call stack, while the time complexity will be big of like, I think the space complexity would be the height of the binary tree, because like depends on like how many say stacks we end up putting to the tree, and the time complexity would be uh big O of n because we will end up say yeah. So I think it's a recursive solution and the time complexity. What's the time complexity? Yeah, I'll look it up and I'll post it in the descriptions. Yeah, let me try running it. Yeah, as usual, I make this very stupid mistake. Uh, I thought this time I got it right, but this very stupid mistake got me again. Yeah, thank you very much for watching, and I hope to see you soon.